I've had a request from a user for some help reducing HPLC data. There's already a video in the Scatter series on this, but we've subsequently upgraded from Scatter 3 to Scatter 4, which looks and behaves quite differently. So I thought I would quickly do another video on how to use Scatter 4 to reduce HPLC data. I usually make these videos on my laptop, a Mac laptop. I thought this time, as for a change, I would actually use No Machine to open a sort of virtual desktop on the cloud at Diamond to do the data reduction remotely. Now, this makes a lot of sense for HPLC data because you tend to end up with hundreds and thousands of DAT files, and it's maybe a pain to transfer all of those files back to your local computer. If you can do the data reduction actually on a machine at Diamond, then that you can just take the one or two files, processed files that you need. I'll just show you. If you go onto the Diamond website and click the For Users, and then this, I've had an experiment at Diamond, you'll find you've got this IT Users Guide on that page. I'm off-site, I'm back home, and I want to access a Diamond desktop, and there's some instructions here about how to download and use this No Machine software to open a virtual window. So this is what I've done. Here is my installed No Machine, and here I am. I now have this virtual desktop on a machine at Diamond on the cloud. Okay, this little activities menu item here will reveal a bunch of different programs you can run. I like to use the terminal, and I'm quite comfortable navigating around in the terminal. This files icon, it will open a graphical file browser like you'd probably be used to on Windows or Mac. Okay, so here I've opened a terminal window. I'm doing a new tab, so I've got two tabs here, and I'll be using both of them. And then, this is my user visit directory. You'll see in here there's a bunch of H5 and Nexus files. These represent your raw data. These are the images and all the metadata from the Beamline. There's another video that talks about how these images are reduced to DAT files. That's done by Dawn at Diamond. And we have a processed subdirectory. And in the processed subdirectory, you have these directories called something _ ASCII. And if we look in those, you'll see that there's lots of DAT files. There's usually about 620. So that's one image taken every 3 seconds throughout a half-hour HPLC run. Okay, you'll notice the images are called with this kind of funny index name. In your top level visit directory, there should be a file called scanlist.csv, and that will contain information about what these files are. They'll have your descriptive title linked to the code name there. Okay, so you could go activities and open the file browser. The file browser in Linux, in this version of Linux, is called Nautilus. Nautilus. And actually, let me just do this. Nautilus, and that is going to open this file browser on that DAT file directory. So we've got our files and we're ready to go. In this other window, I am going to open Scatter. You'll see here I've set up an alias. You don't have to do that, but this is the command that will open Scatter in this Linux system. So I'm just going to go Scatter. Obviously, if you've installed this on your home machine, you can launch Scatter using the little icon or however you do it. So now I've got my files and I've got scatter. So we're processing SEC data. So I'm clicking on this SEC window, and here is the interface for reducing SEC data. Okay, you'll notice down in the corner here, we've got a couple of different little buttons that we can use. This nanometer to angstroms is for when you initially drag a DAT file into scatter. So that would be dragging DAT files into this SEC window, or if you're in the analysis tab, you might drag DAT files into this file opening thing here. And the first time that they're dragged in, it's going to convert from nanometers to angstroms if you've checked this button. I say that because the new version of scatter, when you first process some data, it's going to output a .sec file. And if you drag a .sec file into here, a lot of the traces and things are pre-calculated, so it's much faster. And this nanometer to angstrom button won't do anything in that case. It's only for dragging DAT files in for the time being. Okay, so you don't have to select all the files. It's going to automatically know if you drag one, it's going to look for similarly named files within the directory. So without further ado, I'll drag that in. The desktop on the cloud takes a little while. It's not a super powerful processor. This will probably go an awful lot quicker on your laptop, obviously depending on the specs from your laptop. Okay, so output is going to be saved to this output directory. So I'm going to select that and navigate to my visit directory, which I've forgotten, 26599. Then the processing subdirectory is the one that you have write access to. So do that. I usually create a new folder. This is BSA data. I've already processed it in BSA1, so I'm just making a subdirectory called BSA2. Okay, so all of the output is now going to be saved in this folder, and the output names are going to be BSA. Okay, so my files are loaded. You can see them here, 690. And then I hit this trace button. And again, this is a reasonably slow step. You can see it having a think, and it's telling you what it's doing. So effectively what it's going to do is it's going to run through all of the DAT files in this list. It's looking for files with very low scattering signal, and it's going to make those the buffer blank. And then it's going to calculate the ratio of each, the intensity data from each DAT file, and do a ratio against that buffer blank. And that's going to give something that looks a little bit like an HPLC trace. You can see this is BSA. We've got a big monomer peak, smaller dimer peak, even smaller tetramer peak, and it sort of disappears off into larger and larger species down here. Okay, so this is our trace. You can see in grey we have frames that it's automatically decided are going to be the buffer background. If you like, you could drag a box in a region that you would like to use as the buffer and say set buffer, and instead of using all these automatically generated frames, it's now just going to use the little region or regions that you've selected. If you do that, you have to hit update in order to recalculate this using the new buffer blank. Okay, so then we select the region that we're interested in. I'm just going to select this peak region. Okay, I've just dragged a box over the peak. And you can see over here that it's showing that region, and in red it's showing the RG data. Okay, the monomer peak looks great. We've got this nice flat RG across the peak. Below that is this kind of interesting similarity plot. It was in the old version of scatter, but it's kind of a bit more visible now. Effectively, the way this works is it's a matrix of each of the frame in this region of interest versus itself. So along the diagonal is each frame looking at itself. And then you can see, frame 40, we've done some statistical analysis to compare frame 40 with each of the following frames. And this kind of cyan color is that those frames are similar. So you can see for the monomer peak, we've got this little kind of isosceles triangle where each frame here is very similar to the following frames, but then, the red means, there's a lot of variation in these regions, okay? So the way that you select the region of interest is you're going to click on this similarity plot, and wherever you click, you have to imagine a little isosceles triangle going up to the point you clicked and coming across. So you've selected these frames here. So that would be frames of 330 along to frames of 350, and you can see what that looks like in the selection here, and you can see the output file that is going to be calculated down here. Okay, so for me, I really just want to calculate to average together this region where I've got good signal and my RG looks pretty tight. So if I go up here, I select a much bigger region. As I move back down towards the diagonal, I'm selecting a smaller and smaller region. Okay, and you can see as I select a tighter region here, the signal to noise on this looks like it's improving. So that's good. We're not including a lot of noise in our averaging. Okay, so that looks fine. I'm happy with that, and this is what the output is going to look like. So finally, to output this, we're going to use this merge. Merge means I'm going to average together all of the files that you've selected here. I'm going to average together all of the buffer background files that were chosen automatically here or that you chose explicitly, and then I'm going to do a subtraction. And there it goes, it seems to have finished. Okay, now that is going to output this BSA DAT file into your output directory. Let's just have a wee look at that actually. So if I go into processing, you'll see this BSA2 directory. So there's a bunch of things in here. There's the DAT file, which is this. There's a .sec file, which if you later on want to go back and regenerate these plots and maybe choose a different region or whatever, you could just drag the .sec file into here and it's going to populate all this much, much more quickly. And there's a PDF file that contains a bunch of these sorts of images and information about the data that you can use later. Okay, it's also opened this file in the analysis tab. Okay, and so then in the analysis tab, you can do your Guinea plot, and you can get rid of some of the noisy pixels at low Q. Get your Guinea region looking nice and flat. You can do the normalized Kratky plot. You can, the Guinea peak analysis is just another way of calculating the Guinea with a bit more sort of information, feedback, and so on. I'm not going to go through all of this. I might go through these things later. Most of these menu items are the same as in Scatter 3, so they should be familiar. Okay, so that is how to reduce HPLC data using the new Scatter 4. I hope that was helpful.